Hello everyone. Today in this session we are going to discuss regarding the well hydraulics. As you know that wells form the most important mode of groundwater extraction from an aquifer. While the wells are used in number of different applications, they find extensive use of water supply and irrigation engineering practice. What is well hydraulics? To understand the process in effect when one or more well are pumping from an aquifer, this is, for instance, considers the analysis of drawdown due to pumping with time and distance. Importance of well hydraulics. Groundwater withdrawal from aquifer are important to meet water demand. Therefore, we need to understand well hydraulics to design a pumping strategy that is sufficient to furnish the adequate amount of water. Let's have a glance on groundwater well. The groundwater is collected through the use of wells. Well systems usually have well structure, pump and discharge pipes. Well usually consist of perforated casing that allows water to enter the well but prevents collapse of hole. The waste, the water is withdrawn. The flow becomes established to compensate the withdrawal. Because of head loss, piezometric surface adjacent to the well is depressed and is called as cone of depression. Here we have to remember the Darcy's equation that Q is equal to K into A divided by I, that hydraulic gradient, that is the dH by dx. What are the assumptions in this theory? The piezometric surface of the aquifer is horizontal prior to the starting of pumping. The aquifer is homogeneous and isotropic, same material with the same properties in all directions. All flow is radial towards the well. Groundwater flow is horizontal. Darcy's law is valid. The pumping well fully penetrates the aquifer. Now here you can see a well is there which is extracting the water from a confined aquifer. Now again I will repair here this. You can observe the impermeable, two impermeable layers are there, right? This is a confined aquifer, the water present here, and the extraction is water extraction is we are studying from this well. These are two wells are there which are observation wells. The when you are extracting water, you can see you can observe a drawdown curve here. This is a drawdown curve and the various terminologies are also associated with this. The height h1 is present with the observation well number 1, the height h2 here in case of water, in case of the observation well number 2. Then this is the original water table or original piezometric surface. Okay, above that you can find the groundwater ground surface is there. So our terminology will have to remember. So if you consider the an unconfined aquifer or confined aquifer, you can say lowering rate of water table is takes place on pumping. If the aquifer is homogeneous and isotropic and the water table horizontal initially due to radial flow into the well through the aquifer, the water table assumes a conical shape called cone of depression. The drop in the water table elevation at any point from its pervious static level is called as a drawdown. So you can observe this particular drawdown here, and you can also the this cone of depression as well. The aerial extent of cone of depression constant rate of pumping, the drawdown curve develops gradually with the time due to table elevation at a given location near the well changes with time. On prolonged inflow of groundwater from outer edges of the zone of influence, the break, the drawdown operate under the steady flow conditions. As soon as the pumping is stopped, the depleted storage in cone of depression is made good by groundwater inflow into the static level reached. This stage is called as a recuperation or recovery, and is unsteady phenomena. So recuperation time depends upon the aquifer characteristics. Now when you are taking the water from the or extracting water from this, so this cone of depression and the drawdown curve is observed, right? So when it stops, again this water try to reach its original water table. That is called as a recuperation of the well, or it is called as a recovery. Now steady versus unsteady or transient flow, you can say. Steady state implies that the drawdown is a function of location only. Transient state implies that the drawdown is a function of location and time. Thus, H is equal to Fr in case of steady state, and H is equal to Frt in case of transient state. So, as a transient state implies that the it's a function of the location and time. Okay, here in case of steady state, it is a function of the only location. So this we have seen all these terminologies. So how the equations are formed in the steady radial flow to a well in confined aquifer. So steady radial flow in a confined aquifer, when the water is pumped from a confined aquifer, the pumpage creates a drawdown into piezometric surface that includes hydraulic gradient towards the well. Drawdown at given point is the distance by which the water level is lowered. A drawdown curve shows the variation of drawdown with distance from the well. The induced flow moves horizontally towards the well. Thus, now applying the Darcy's law to derive the flow equation that relates to drawdown pumping. So you can observe here the pumping is water taken place, and the flow of the surrounding water is towards the you can say through the aquifer takes place that. So the equation that Q is equal to A into Q. Now here the area in this will have to consider by taking these parameters, where 2 pi r into B, where the gradient will also consider here the coefficient. So minus k into dH by dr. So final equation, remember, as per the Darcy's law, which is applicable for this well, that minus 2 into pi r B into k into dH by dr. So this will be again more easy to understand when the numerical examples you are solving. The conditions at the well when H is equal to HW and R is equal to RW, and the age of the aquifer is H is equal to HW and R is equal to R naught, yields the negative sign here neglected. Okay, so here you can see here when regarding the height H, in this case this H naught is there and HW is there, and when you are discussing regarding the drawdown, so H you can find out here. Okay, so HW and H naught, so and again you can find out the radial distance. So in that case, so you can write down that H naught minus HW is equal to Q divided by 2 pi K into B log natural R naught divided by RW. So again coming to the same equation, here we have to more concentrate on the original piezometric surfaces, and the drawdown curve. So, the final equations are becoming now as Q is equal to 2 pi kb in the numerator H naught minus HW divided by log natural R naught divided by RW. It becomes Q is equal to 2 pi kb into H minus HW divided by log natural R divided by RW, and its general form of this equation that HR is equal to HW plus Q divided by 2 pi into KB log natural R divided by RW. So, Thiem's equation can be finally written as the T is equal to K into B, which you can write down as Q divided by 2 pi into H2 minus H1 log natural R2 divided by R1, where R1 and R2 are the distances of H1 and H2 at the heads of respective observation wells. That here you can see this H1 and H2, and you can see these are the observations wells. These are the distances R1 and R2 which are written here. Now again, where when you are finding the permeability, so there is one equation which is a you can say a proven equation that Kb is equal to 528 Q log R2 divided by R1 divided by m into H2 minus H1, which is a empirical one. So only you keep in your mind where that Q is a discharge, Kb is a permeability, and R and H are the distances which are measured, and M is the this thickness of aquifer. Now, from a practical standpoint, the drawdowns rather than the head H is measured, so the T is equal to Q divided by 2 pi S1 minus S2 log natural R2 divided by R1. So today we have seen regarding the how water is extracted and what are the equations which are associated with the a drawdown, or you can say, or extraction of the water from a well, which is associated with the confined aquifer. So in the coming sessions we are going to see the equations which are associated with the water extraction from a unconfined aquifer. So thank you very much for joining the today's session.